Are you ready to unlock the secrets of ChatGPT and discover the AI power within? So in this introductory presentation, we will discuss what ChatGPT is and provide a brief overview of the course content. So first of all, we will discuss the definition of ChatGPT, the purpose, and how it has evolved over time throughout this presentation. But by the end of this section, you will have a solid understanding. It will be crystal clear for you of what ChatGPT is and how it can be applied in various contexts. So ChatGPT, Chat Generative Pre-trained Transformer. Keep the word transformer. It is a key word. So it's a powerful AI language model, which means that it is an advanced natural language processing model developed by OpenAI. So it utilizes a deep learning architecture known as the transformer. Transformer is the heart, is in the core of this ChatGPT. So to comprehend and generate human-like text, it is used this transformer that we will analyze. This transformer makes it a powerful tool for a wide range of applications. So what is a transformer? The transformer is a powerful language model that helps computers understand and generate texts. It focuses on the relationships between the words in a sentence, and it focuses on the importance to each other, the importance each word has to each other. So the transformer uses a unique method that is called self-attention to do this. It also considers the position of each word in a sentence so that it can understand the word order. The transformer consists of two parts, two main parts. The first one is the encoder. The encoder processes the input, and the decoder that generates the output. So this architecture led to many advanced language models like GPT and like BERT from Google. So let's analyze a little bit more the transformer with a simple example. Imagine you and your friends are playing a game called Word Transformers. So in the game, each of you takes turns saying a sentence. The next person has to change a word or change two words to create a slightly different sentence. The goal, the purpose of this game is to keep the conversation flowing smoothly. Now, let's say that there is an invisible robot, the transformer, as you can see right here, listening to your conversation. This robot wants to join the game and make sentences just like you and your friends. So in order to do this, in order to make the robot join the game, the robot must learn how words work together and must also learn the rules of the game. So the transformer has actually a unique way of learning. It breaks down sentences into smaller parts. These smaller parts are called tokens, like words and punctuation. So we take the sentence and we break it down into smaller parts that are called tokens. Tokens are words and punctuation. And this transformer tries to represent these words as little balls in a 3D space. So each ball has a special color, special glow, depending on the word it represents. When the robot turns to play, it looks at the positions and the colors of the balls, which actually are words from the previous sentences. So it pays attention to the order of the words, and it can create a new sentence that makes sense. So the transformer picks the words, it thinks if it will make a good sentence or not, using what it has learned from observing you and your friends. As it plays the game more and more, it gets better understanding the rules, and it tries to create sentences that will finally fit in with your conversation. This is a general example to understand what tries to do the transformer in real conversations between you and your friends or whatever in the internet. So the transformer uses a specific architecture that we will analyze in the next lectures. The transformer architecture is based on the concept of self-attention. This architecture allows the model to weigh the importance of different words in a sentence relative to each other. This self-attention mechanism enables the model to capture long-range dependencies and to capture complex relationships between words more effectively than other architectures. For example, other architectures are RNN, recurrent neural networks, or long short-term memory networks. So this architecture is more powerful. You can see some key components of the transformer architecture that we will analyze later. The first one is self-attention. The self-attention mechanism computes the relationships between all words in the input sentence, allowing the model to capture contexts and to capture dependencies between words. This mechanism gives each word a different weight, a different number that represents the weight, based on its relevance to the target word. We have multi-head attention, that the transformer uses multi-head attention, multiple self-attention heads, so that it can focus more on different aspects of the input sentence. This allows the model to capture a richer understanding of the context. Then we have positional encoding, so that the transformer architecture does not have any inherent sense of the word order. Positional encoding is used to inject information about the position of each word in the input sentence. Then we have feed-forward layers. Feed-forward layers, so in addition to the self-attention mechanism, the transformer includes feed-forward layers that are responsible for processing the information that is aggregated through the self-attention process and making predictions. Finally, we have the layer normalization that is used to stabilize the training process and improve the model's performance by normalizing the inputs of each layer. And the encoder-decoder architecture, where finally the transformer is built using an encoder-decoder structure. Don't worry, all of this will be analyzed in the next lectures with specific examples and will be crystal clear for you. This is just an overview if you're going to revise some things that you can see all these components together. Let's see now an example. Let's suppose you have a sentence. John went to the store to buy apples. So the transformer receives this sentence as input and breaks it down into words. The self-attention mechanism looks at each word and calculates its relationship to other words in the sentence. For example, it might recognize that John is related to went and buy, because John is the one performing the actions. It also considers the position of each word to understand the word order, like store comes before apples. So the encoder processes this information and creates a representation of the sentence. The decoder then uses this representation to generate a response or complete a task, such as translating the sentence into another language or answering a question about it. This is a very simple explanation of how the transformer works. In reality, it involves complex mathematical operations and multiple layers of encoding and decoding to understand and generate the text. The applications of ChatGPT, there is a wide range of applications. We have content generation and summarization, so either we want to generate massive content or we have massive content and want to summarize it. We have language translation, we have customer support and chatbots, sentiment analysis. Its versatility makes it really an invaluable tool for businesses and individuals. So, in conclusion, ChatGPT is a powerful AI language model that has fundamentally changed how we interact with and how we process text. Understanding its capabilities, understanding its limitations is really critical for realizing its full potential in a variety of applications. So we will continue. In the next lecture, we will explore the foundations of natural language processing and its role in the development of ChatGPT, so stay tuned. So, the primary purpose of ChatGPT is to generate contextually relevant text based on user inputs. So it is designed to respond in a conversational manner, understanding and processing vast amounts, huge amounts of textual data. This capability allows ChatGPT to be highly versatile and applicable in various settings. So this, as you can understand, is a component of which has undergone several iterations. The initial GPT model had limited capabilities, whereas GPT-2 improved language understanding, language comprehension, and generation. As of 2021, the most advanced version, GPT-3, has over 175 billion parameters, making it a highly sophisticated language model. While GPT-4 is reportedly about 6 times larger than GPT-3, which means GPT-4 has 1 trillion parameters. 1 trillion parameters. Oh my god. Okay, so this is it.